Welcome to Visual Composer tutorial. In this video, I'm going to talk about the concept of array. So in Visual Composer, array is just referring to a collection of objects. For example, you can have a single image. You just drag in an image, and this will just be one single image. You can also drag in multiple images, and you will see this new dialog asks you to import multiple images as, and if you select image array, you will get a similar looking node. But if you see the output junction here, you will see that it looks different. One of them is kind of like empty. The other one have this color inside, right? You can hold shift to preview the content inside the junction. This one only have one data, but this one is a surface array. It contains multiple surface. You can also have like an array of number. You can have node like array range if you just output multiple number, right? Or array of number. Now most of the nodes in Visual Composer are made to process array data. So for example, something like a blur node. You can connect image into blur node, right? And it will blur an image. But you can also input an array into the blur node as well, and it will blur every single image in that array. And not just the surface input, you can also connect array into other property as well. Like here I have another array of number 1, 2, 3, 4, right? If I connect this into the size properties, it will combine two arrays together, and they're gonna say, okay, the first image we have the size of 1, second image we have size of 2, the third of 3, the fourth of 4. Right, so it's gonna match the index in each array in each input. Now what you can do with the surface array is you can use it in different composition node, stuff like the stack node. You can plug array into it, and it's just gonna stack all the image in the array. We have the image grid, same thing, right? But we can set the grid size. We have stuff like the pack sprite. This one we use different sprite packing algorithm. We also have the dedicated sprite stacking that can accept image array as well. Right, this is not the best example because each image is not made for sprite stacking. You can import like a sprite stack slice as an array and then plug it to the sprite stack, and it will stack it into this pseudo 3D stuff. Now you can create an array of number using a node like array range. You can also combine multiple data into array by using the array node. This you can just plug in the output into it, and it will just combine it into a new array as well. Right, and with array node you can even like combine multiple data types into one array. This is not really recommended, especially if you don't know what you're doing, because if you try to plug this in other node, it's definitely gonna get confused. But you can do that. Another common node for creating array is the vector node. So a vector is just another name for an array with fixed size. Like a vector 2 will just be an array of size 2. Right? A vector 3 is an array of size 3, and vector 4 is an array of size 4. Right now I create this vector node using the hotkey, so I can just press 1 for number, 2 for vector, 3 for vector 3, and 4 for vector 4. And this vector 2 data sometimes also called point, because it just represents a point into this space, right? X and Y position. So when you see a node that talk about point, it's also referring to a vector data as well. And you're gonna use this array of point or array of vector 2 in other node, like the scatter node. So by default, the scatter node will just take in a surface and then scatter it randomly. But if you want to have more control over the position where you want to scatter the surface, you can do that by going to the distribution property here, and you can set it to point array. In the older version, it will say direct data, and it's kind of confusing, so I changed it to points array. And as the name suggests, you put in array of point or array of vector 2 into it, and it will scatter based on each of these vector. Maybe it's too small. And you can see here, it's just gonna scatter at 0, 0, 16, 0, 0, 16. I don't know why I choose this number. You can barely see it, but it's there. But you're probably not gonna construct an array of point directly like this. Another way you can create array of point is to use path. So I'm just gonna use a path. This time I'm gonna use the shape path. Now I haven't talked about path yet. It's gonna be in the future tutorial. But a path data is just, a path, right? I can set it to the ellipsis shapes, and then I can use like a sample path, which will sample a point from a path. Again, the point is just vector 2. As you can see here, I give it the ratio on the path. And you will notice the point here, it's just moving around the path, right? Now the output here is just 1 point. If I want to sample multiple points from inside this path, we can go to the ratio properties and then give it an array. I can just type in array directly in the text box as well. I'm gonna sample point at 0, 0.2, 0.4, 0.6, 0.8. Press enter, and you will see it will now sample multiple points from that path. And if I connect the position property here to the scatter node, I will now be scattering a surface along this path. Now, in the scatter node, there actually are path distribution types. You can plug in the path directly to it, right? And you can do like basically the same thing. But this is not a path tutorial. This is an array tutorial. And you can get array data from other sources as well. In the add node dialog here, in the values and number, you will also see a number of nodes that related to point stuff, right? You can have this another node. It's a lattice point. This one will just output a point in a grid or in a lattice. Or you can even add 3D point. Here we have lattice point and lattice point 3D. Here it will generate a point in 3D space. Now if you try to connect the point here into the scatter node, and the output gonna look a little bit different because the scaling in 3D are different from the scaling in 2D. If you hold shift by looking at the output here, you will see that it only fixed at 0 to 1, and it doesn't know what direction, what camera you're looking at. So it's not gonna give you the result that you want. If you want to convert a 3D point into 2D, you can do that with the 3D point camera. So you connect it to the 3D point camera, and you will have a different camera that look at the 3D point and then output into 3D space. Right? You will see that the point and now look a little bit different. I'm gonna adjust the remap range in the point camera here. We make it 0.5. It's actually quite hard to see. Let me make it bigger. And here, as you can see, we are projecting a 3D point into a 2D space using this camera, and then we scatter it. And as I rotate the camera, you will see that it will now rotating the point, right? Yeah, we also have the scatter point 3D as well. This is also similar to lattice, right? But instead of this uniform point, we have the random point. Now we also have the transform point. This one will take 2D point and then transform it. So you can like move the point left or right. You can rotate it, or you can scale it. Right, and here I talk about point, which is another type of array. But let's just go back to the concept of array, because there are more things that you can do with array as well. If you open the add node dialog, in the value section here, and in the array, you will see that there are a bunch of nodes related to array, both creation and manipulation. You can get the length of the array. It just return the size or the amount of member in an array. You can get a specific values from an array. You can also set it as well. So set a specific values inside an array. Another useful node is the array split. This one is used maybe with the surface array like this. You can connect it to array split, and it will just split out each member in an array into their own output. I'm not gonna cover every single array node here. Most of the time, you only need to like get a member from an array or set a member in an array. We also have this group operator section. This is for more complicated array loop. So you can, for example, loop a member inside an array. If you have an array length from 0 to 9, you connect it to the loop, and we can do like maybe we just add it by 10. And what we will get is, well, just each member add by 10, right? From 10 to 19. Now this is not a very good example because the math node can also accept an array. So you can just plug array in here and then plus 10. It will work the same way. It will also be much lighter, right? But here, it allows you to create more complex array loop. With a surface array, we can do maybe give it some outline. You can maybe do an average color of each of the image and then use it as an outline colors. Right now, each surface will have outline color based on its own average color. And another inline node is the filter array. This will allow you to filter out the array using some condition. I'm gonna plug in the surface array. I'm gonna get the average value, and I'm gonna say I'm gonna get color data and then do compare greater than 0.5. So now I'm basically create a filter that will only select a surface that its average color have hue higher than 0.5. Or maybe we can change the condition to maybe a brightness, right? This might make more sense. A brightness higher than something. So now we filter an image based on the brightness of its average color. You can also sort an array using condition. I guess we're gonna use the same concept, right? Just get average color. And maybe like this, sort color by its average brightness. Or maybe we can use hue instead, because the brightness of the average color is kind of hard to see, since we have like the dark area here and the bright area in our image. If we use hue instead. Oh yeah, that makes a lot more sense, right? Put it in stack. As you can see, we are arranging an image based on its average hue. So there's a red here and red here. I'm not sure why. Probably because the brown here kind of skew the average a bit. But in general, you can see that we are sorting the image based on this hue. Right, and that's all the way you can manipulate an array in Pixel Composer. The last thing that I want to mention is the concept of matrix. Now, I'm not going to talk too much about this because it's quite complicated stuff, and you're probably not going to have to interact with any of these nodes. But if you have to, if you want to, then I'm just going to tell you that there are a number of nodes related to the matrix stuff in the matrix section. I guess the most commonly used matrix node will be stuff like the convolution. If you know what it is, then you probably might want to use it. If you don't know what it is and you use node like blur node or edge detection node, then you probably don't need this node. But there are also other matrix related nodes as well. Node for generating matrix data, for getting like determinant, dot product, eigenvalues. This one is new too, so yeah, I just added. You can get eigenvalue of a matrix from in Pixel Composer for some reason. But you can. I'm just mentioning this because I don't think that there's gonna be any situation where I would have to mention it again. I guess we can talk about one last application is in Pixel Composer feature video. And in this video as well, we're gonna show you the list of Patron supporter on the screen, right? Those are also made in Pixel Composer using the array system as well. So I have the Patron file that I get from Patron. It's in as a CSV. I parse it, turn it into an array, and do some array processing here. Get the draw text node. You can just plug in the array of text into it, and it will just draw it into a separate text. And then we have all the composition things here, animation, to get the final image. So that is one application that I actually use all the time. Now this setup also use stuff like the atlas and the stacker and stuff like that, which I haven't covered yet. It's gonna be in the later video. But I think you can imagine what you can do with the array system in Pixel Composer. And I think it's a really powerful tool that you don't commonly see in other VFX software. So that will be all for today's video. So thank you everyone for watching. Special thanks for the Patreon supporter, and see you in the next one.